I'll just talk briefly about the MultiPort Inlet. Jamie was really excited when it came in. It's a good system. So I'll go through how it works, a few possible applications for it, some considerations when you're using it, and then show a little bit of data on some experiments we did in the lab and some future plans possibly for the system, things we've been tinkering with, which some of you might have seen when you were in our lab. So, those of you with Syfts, the difference visibly from the external is the sample port is just replaced with this 14-point position. So 14 points, the system automatically switches quickly between the different ports, or it can be automated depending on how you set it up. Each of the ports are then routed through the capillary and it's all heated, and the operation is pretty simple if you know the software. So with the cover plate off, you can see that there's heated cartridges, so these white tubes that runs all the way around that maintains temperature within it. There's usually more insulating materials around that, but it's taken out for the purpose of the picture. Each of the inlet ports, and then underneath there's a switching valve that just directs the flow from the port through the capillary. The flow restricts the flow, and then into the flow tube, where thereafter it's pretty much the same as other systems. So the difference in the valves, so there's actually 16 ports within the system. So there's the 14 sample positions plus one for the calibrant and a closed position. To set up methods, so any of you that have used LabSift before, so this is the method screen and the settings tab, and the only difference is you enter which port you want in your method, and then it'll automatically go to that port when you run that method. So running a batch, so this is just an example of the 14 ports all queued up in sequence. There's no need for it to be sequential. You can go in any order, and it'll do one method, move to the next, run that method. And the methods can be wildly different, so you can look for formaldehyde in one thing and DCM in another, or all the same, depending on your application. So, some possible applications for it, and I'll just go through a few of them as examples. So, like some process monitoring, these are just stock images, not examples that we actually have, but examples here. So the first one shows a water treatment facility, so there'll be parallel treatment processes based on the amount of water, and you can check the efficiency based on the VOCs that are left after any treatment, and see if one line's failing, and then divert to others if it's well, you maintain that. Then more sort of continuous manufacturing or batch thing, so you can be looking at production of a product through its from raw ingredients to final product, monitoring different endpoints to allow the triggering of the next step within the process. One example that's the MultiPort Inlet is currently being used for extensively. Syft have sold a lot of systems to clean air monitoring. So here it shows, and I've stolen Vaughn's image, sorry Vaughan, the one Syft with tubing connected to various points within the factory, and they're monitoring for changes in the ambient air. If a flag comes up, they can stop production, and then they don't lose product, raw ingredients that would need to melt down and rebuild. They can then investigate, clean it up, and start again in that area. Another example is occupational exposure monitoring. So a lot of refineries and the like, or factory floors as well, will have safe working limit exposure limits that operators can be exposed to during their working day. The Syft can monitor the different locations and flag if at any point an acutely high level comes, or potentially monitor throughout a day and measure a chronic exposure within that, that location where an operator might be working. Alternatively, in a more lab scaled thing, you can use your 14 ports to connect to canisters. So this here shows evacuated canisters going out, collecting samples, and then bring them back to the lab, hook them up, and Syft can go through each of them, and you can be replacing as it's doing them, just to get the efficiencies. So a few considerations when you're connecting your Syft. Distance between your sampling point and your Syft may be an issue. So the Syft will draw approximately 25 mils a minute of gas. If you've got a piece of tubing, 1/4 inch, 1 metre length, that's got a volume of 12.5 mils. So it's going to take about 30 seconds to go from end to Syft. You can reduce that by switching to 1/8 inch tubing, and we've done that in the lab, and that cuts it down to 12 seconds, but there's still a delay between the two. So, possible solutions to this, if it is an issue, it may be that that 12 minute, however long it is, doesn't matter for your application, but you could simply fit a pump to your tubing between the sampling point and the Syft, so it's drawing the air through it at a faster rate, and then the Syft just tees in and takes what it needs, so you get a more instantaneous measurement. Other considerations is heating of the interface between your sampling point and your Syft. So if you're working at ambient temperature, maybe doesn't matter. You might get some effects on the pipe work that's going between it. But if you're working in a heated system, then you best maintain temperature to match where it's coming off. You don't want it to be volatile in one place and then just condense out in your piping. So consideration of volatility and polarity. And then to resolve this, heated transfer lines are available that prevent, or at least reduce, any loss of analyte to the tubing. So we did some tests on the system with a MultiPort Inlet in Anatune. We set up a micro chamber, so it's a heated chamber with a flow through of gas, and put in 3 different sample types that we know off gas, different compounds. So polystyrene, which gives off styrene, polyoxymethylene gives off formaldehyde, and cardboard, which gives off methanol and various other VOCs that we added to a method. Yeah, methanol and acetonitrile are 2 examples. There's a long list of things that off gas from it. We set up a method for them. You can't see the method. Resolutions 1. And then we did a test. And this is a tested technology. So we've got it set up. We've just got 4 different chambers set there. I think we had 3 with the off gas and 1 with just a blank. As I say, our different samples. Load the method, set it scanning, and we were just doing this manually switching the valves, so we automatically picked them ourselves. So scan starts, and currently all valves are closed. So we get a few data points closed, just navigate to the to where the different valves are. So as I say, it's closed there. Open up the first port, and near instantaneously we see which one's that one? I can read it on this. I can read that. So that's going to the cardboard, so we're getting a methanol peak come off. Again, switch valve, the methanol signal drops, and styrene kicks into the next chamber, polystyrene within it. Again, switching, and rapidly the off gas and changes, and now we see formaldehyde from the POM. There we go. It's got, yeah, Mark's formaldehyde. I think Mark just walked past and the formaldehyde went up.
Embalmed.
And then at the end we just closed it and it all went back to baseline. So this is just the data file coming out. So you see at the points we change it, it's a rapid switch from what it's detecting. It's a very fast switch of the valve. And you see the different off-gas chemicals. The latest thing that we've been doing in the lab is trying to see if we can utilise one of these ports to allow automation as well. So we've knocked up a bit of a prototype with MPS on top. So we've added, as a lot of you probably saw in the lab, injectable inlet to the system, just taking up position 1 on the 14 ports. And we've done some injections of this. So again, a couple of things. So we're just doing a headspace extraction from a vial, and it's the standard plot you see when you're doing automation of time between the time when the sample's not been added, then it gets, top is when the sample's actually, the headspace has been added to the system and then goes back to baseline when the injection ends. So that's styrene and formaldehyde. Again, off-gassing off the same polymers. So current limitations to our system, because it's early days, so the only heating to this is coming from residual heat from the base plate, the 14 port plate, and we've installed the heated transfer line to the makeup gas. So here, so it's coming out hot, so it's passing some of that heat through to get as much heat in as possible. So far, we haven't looked at very volatile, non-volatile material or sticky things, so we'll do a bit more testing maybe with compounds that are more likely to stick around and see how it transfers in. But it may be that we need to do some better heat exchange. I mean, we've also got a lot of connectors just because that's what we had round, so there's a lot of potential cold zone. So thinking about this and whether it's a benefit, so by having this injectable inlet, it potentially allows you to do a calibration as well as running the running your system for your monitoring points just by doing injections into it. So it gives you two systems in one, which means you don't have to switch between the different heads. So at the moment you have to unswage your injectable inlet to put your elephant trunk on or whatever. So, and you don't need to shut down to do that as well, so less downtime. So we've started working on this. Is it something that people would see of use and worth further investigation?
You could use all the inlets on it, definitely.
Yeah. That let's move. Thank you.
So, yeah, thanks, Colin.
Yeah, I have a quick question on the 14-port system. Have you compared the measurement between each port, and especially if you have like, for example, in my case, high pressure sample, so I need a bypass. Have you tried the system with several bypass just to see how it works and if they are really equivalent?
So we've only really got one proper heated transfer system. So we've attached it to different ports and not noticed any significant difference. We haven't, as one test, switched one straight after the other, so there's been time but when we had to unscrew, screw back in and everything.
It will be quite interesting if you have like a compound which is really sticky, because then you can have like feeding several lines at the same time and get everything kind of coated or conditioned at the same time. That will save you time, because every time running with one inlet, you have to change, and then you have like probably 10-20 minutes of conditioning. So you're basically spending a lot of time conditioning. If you have
So that's right. Yeah. So the
condition
before the
my
SIFT,
line
yeah.
at the same time,
Yep.
then I could do all my measurement probably in 5 minutes.
Yep.
So that would be really interesting to see how all of these compare.
Yeah.